Let's do one more of those. Next, I'm going to factor 5x squared minus 16x plus 3. Remember, I'm trying to compare this to ax squared plus bx plus c. So you don't have to write it this way, but it might be helpful to change the minus 16x to plus the opposite of 16x. That may help you a little bit in terms of seeing that instead of an a, we have a 5, instead of a b, we have a negative 16, and instead of a c, we have a 3. Remember, the first step in our factoring is to find two numbers that multiply to AC but add up to b. In this case, AC would be 5 times 3, which is 15. And b is negative 16. Now, if these two numbers multiply to a positive number but add up to a negative, we're going to have to think a little bit about that. If the two numbers multiply to a positive value, that means they're the same sign. They're either both positive or they're both negative. And if they add up to a negative, well, then that means they're both negative. So I'm trying to think of two negative numbers. They multiply to positive 15. They add up to negative 16. Again, if you can think of it after a few seconds, that's awesome. If not, start counting and make a list. I can do 1 times 15 to get 15. I remember we said they're both going to be negative. 2 doesn't work. I can't do 2 times anything and get 15 with integers. I could do 3 times 5 to get 15. 4 doesn't work, and then 5's already on my list. So the only factors are 1 and 15 and negative 3 and negative 5. The first set of factors add up to negative 16. The second set add up to negative 8. I wanted the ones that added up to negative 16, so I want the negative 1 and the negative 15. Once I've found those values, recall that we're going to replace the middle term with those two values. So I'm not touching the first term, and I'm not touching the last term, but I'm replacing the negative 16x with a negative 1x and a negative 15x. Now that I've got 4 terms, I'm going to use grouping, which is where I put the first 2 terms together in parentheses and the second 2 terms together in parentheses. Now I'm treating each of these binomials as its own separate GCF problem. So 5x squared minus 1x. They are both divisible by x. Then I do the opposite of distributing. I ask myself, x times what is 5x squared? X times 5x is 5x squared. X times what is negative 1x? X times negative 1 is negative 1x. Copy the plus sign. Think of the GCF between negative 15x and 3. Because my leading term is negative, remember I'm going to be taking out a negative, and 15 and 3 are both divisible by 3. That's my GCF. I use the opposite of distributing to figure out what's left in the middle. I ask myself, negative 3 times what is negative 15x? Negative 3 times 5x is negative 15x. Negative 3 times what is positive 3? Negative 3 times negative 1 is positive 3. Remember that if I've done this correctly, the binomials should be the same, and I'm going to factor out that common binomial. When I go to my first term and I take out the 5x minus 1, I'm left with an x. Copy the plus sign. When I go to my second term and I take out the 5x minus 1, I'm left with this negative 3. Now for my final answer, I'd probably say that it would be better to change the plus negative 3 into a minus 3. So make this a 5x minus 1 and an x minus 3 for our final solution. Remember that you can check your work by distributing. So I'm going to do a quick little check here. Remember that factoring is the opposite of distributing. So if I distribute my answer, I should end up with the original problem. So if I distribute, I'd get 5x squared minus 15x minus 1x plus 3, and I've got some like terms. So then I get 5x squared minus 16x plus 3. So yes, that one is correct.